need to be able to fit logarithmic equations to data using the logarithmic regression function in your calculator. So what you're doing when you do the logarithmic regression, you're given a set of data, you enter them into your calculator, and then when you find the logarithmic regression, what your calculator does is fit a log function to the data. So let's have a look at an example. On page 473 of your textbook, there is a table showing the magnitudes of various earthquakes and the energies released. So the question is asking us, given this energy of earthquake, what is the corresponding magnitude for this? In order to do that, we need to find a logarithmic function that fits this data. So we need to pull out our calculators. Okay, so we need to enter the data into a list. If it has stuff on it already, hit clear on the top of the column and then down, and then it clears. So start entering the data. 63, 2000, 63,000, okay, and then enter the magnitudes. At this point, the number of rows in each column should match up, otherwise you'll get an error later. Now to find the log function that fits the data, we do Ln Reg, and by default it takes Ln, the values in column L1 rather, as x values, and the values in column L2 to be the y values. So if you calculate the function there, that's what you get. And so if you want to graph this, you would have to write this stuff down and then enter it manually in here. There's a shortcut though. So just go back to when you find the logarithmic regression and then tack on a y1. So this will tell it to find the logarithmic regression and automatically put that equation into y1. So hit enter. There's the equation and it's automatically there. Now we want to calculate the magnitude when the energy is 1.1 times 10 to the 16 kilojoules. So in this equation we've got negative 1.1998 plus 0.2895 times the ln of x, y. As I mentioned earlier, it takes these numbers as x if you put them into L1 column, and it takes these numbers as y if you put that into the L2 column. So if we want to find the magnitude when the energy is 1.1 times 10 to the 16, we'd put 1.1 times 10 to the 16 in here. Inside the ln. Alright, so back to our calculator. If we graph this, we want to find the value when x is 1.1 times 10 to the 16. Okay, it's going to say invalid because it's not zoomed properly. So we're going to have to zoom out before it's going to allow us to find 1.1 times 10 to the 16. Let's go ahead and make the x max 2 times 10 to the 16. See what that does. So let's see if that will allow us to calculate the value at 1.1 times 10 to the 16. And it does. So 9.49 is the magnitude of the earthquake when the energy is 1.1 times 10 to the 16. The final answer, M is 9.49. So the magnitude of the earthquake releasing 1.1 times 10 to the 16 kilojoules is 9.49.